Hello and hi everyone, my name is Najahanis binti Zainuddin with number metric 152956. I will answer the question from part 1. From this question, I can say that the equivalent dose is well known in radiobiology that densely ionizing radiation such as alpha particle and neutron will cause greater harm to the tissue or organ than gamma rays and electron at the same mean absorbed dose. Ionizing radiation exposure to living tissue can result in biological damage that can result in disease like cancer or genetic abnormalities. The type of radiation and the amount of energy deposited in the tissue are two variables that affect how severe the damage is. From this formula that I stated in this question, I can explain that equivalent dose HT is calculated by multiplying the absorbed dose to the organ or tissue DT with the radiation weighting factor WR. This factor is dependent on the type and energy of the incident radiation. The absorbed dose is a measure of the energy deposited in the tissue per unit mass, typically measured in unit of rate. 1 gray is equivalent to the absorption of 1 joule of energy per kilogram of tissue, which is termed in Sievert.
Hi everyone, my name is Umi Ilatushifa binti Badro and I will present part 1 about the weighting factor and RBE. So let's proceed. The radiation weighting factor, WR, is a dimensionless factor that takes into account the RBE of the radiation. The value of WR is 1 for X-ray, gamma rays and beta particles, but higher for proton, which is equals to 5. Neutrons is between 5 to 20 depending on the energy. Alpha particle and heavy fragment is equals to 20. The RBE is a measure of how much more biological damaging a particle type of radiation is compared to a standard reference radiation, which is typically X-rays or gamma rays. The RBE depends on the energy and LET, which is the linear energy transfer of the radiation, as well as the tissue type and other factors. As an example, the weighting factor or RBE of plutonium-238 is between 10 to 30. Thus, the Roentgen equivalent in human is 10 to 30 Roentgen in air. Similarly, the dose equivalent following alpha emission is larger than the absorbed dose, which is confined to an immensely small area in human tissue because alpha irradiation travels only a short distance in tissue and has a high LET.
In summary, the quantity equivalent dose HTR is a measure of the radiation dose that takes into account the relative biological effectiveness of different types of radiation. It is an important quantity for assessing the potential health effect of exposure to ionizing radiation and for setting radiation protection standards.
My name is Siti Aliyah binti Jifri. My metric number is 153549. The questions for part 2A is a dose of 99 MPC DMSA is prepared and calibrated to contain 5.0 MCI at 8 AM. The patient arrives late at 10 AM without using any tables of decay factors determine what activity will remain in the dose at that time. To answer these questions, we have to follow the following steps. First step is we have to identify all the key points used in the questions. As we can see here, the dose used is 99 MTC DMSA. According to the National Institute of Health website, we found that the half-life of technetium 99M is 6.04 hours. The time interval between elutions and preparation is 2 hours because from 8 AM until 10 AM. The initial activity is 5.0 MCI. Second step is find suitable formula to determine what activity will remain in the dose at the time. According to Human Health Campus website, the formula is AT equal to A naught multiplied by exponent to the power of negative lambda multiplied by T, where AT is activity in 1 ml eluate at the present time of preparations. A naught is activity in 1 ml eluate at the time of elutions. Lambda is decay constant of technetium 99M. And T is the time interval between elutions and preparations.
Hello and good morning. My name is Aifazleka binti Zami with matrix number 153875.
Next, step 3, we calculate the decay constant of technetium 99M using the formula lambda is equal to ln 2 divided by half-life of technetium 99M, which is 6.04 hour. Decay constant is proportionally between the size of a population decreases because of radioactive decay. The answer that we got for the lambda is 0.114759. Last but not least, move to the last step, which is calculate the remaining activity in the dose of that time using the formula according to Human Health Campus. AT is equal to A0 multiplied by exponent to the power of negative lambda multiplied by the time elapsed since calibration, which is 2 hours. And the answer for this question is 3.97 MCI.
Assalamualaikum and hi everyone. My name is Nur Nazira binti Zakaria, metric number 153604, and I will present part 2 question B. What is 50 rem? 15 rem is the limitation dose annually for the tissue and lens of the eyes of radiation workers. The lens of the eye is one of the body's most radiosensitive tissue. Rem stands for Röntgen equivalent in Mach, which is a unit used to measure the dose equivalent or effective dose, which combines the amount of energy from any type of ionizing radiation that is deposited in human tissue along with the sensitivity of the exposed organ or tissue to radiation. For beta and gamma radiation, the dose equivalent is the same as the absorbed dose. By contrast, the dose equivalent is larger than the absorbed dose for alpha and neutron radiation because these types of radiation are more damaging to the human body. Thus, the dose equivalent in REMS is equal to the absorbed dose in RAS multiplied by the quality factor of the type of radiation. The related international system unit is the sievert, where 100 rem is equivalent to 1 sievert. This unit is used to assess the potential health risk associated with exposure to ionizing radiation, such as during diagnostic or therapeutic procedures using radioactive materials.